Alright, good afternoon, guys. First of all, I want to apologize to you guys for not being able to be present today, this afternoon. I had something come up that I had to take care of. And secondly, unfortunately, because I am not present, your presentations will not occur today. I might reschedule them, so I kind of changed the plans a little bit for today. Okay? So what I'm gonna do is this videos that you guys were working on as groups. I want to make sure that we all, as a class, understanding this whole concept of compound sample spaces and how to do tree diagrams and how to read tree diagrams, especially, and how the tree diagrams can help us as far as probability goes. So just follow along the video, take some notes, and I'll give you further instructions uh, as the video goes on. Okay. So if you recall from last time, we started 14.2, and 14.2 was just a continuation of what sample space is, but it was with compound situations, which meant that you were going to have situations in which you were choosing more than one thing to create an outcome. So the example that we had last time was we started the lesson with the whole pizza special and creating the tree and how many possible outcomes you would have or how many possible pizzas you would have. So that's what we talked about last time. So what I'm going to start the video on is I'm actually going to start with problem number 2, which is one of the problems that I assigned for one of the groups. So I'm going to go over problem number 2, give you some pointers as far as how to work these problems out, and let's go ahead and get started. Okay. So on problem number 2, you have it says a student council election. You have Wen, Joshua, Tamara, Miguel, and Khalil who are running for student council. Okay. The student with the greatest number of votes is elected president, and the student receiving the next greater number of votes is elected vice president. It says to create a tree diagram to represent the possible outcomes for the election. Okay. Your tree doesn't have to look exactly like mine, but this is the most efficient way that I can think of doing this. Well, first of all, one of the things that I want to bring to your attention is that it says that once the student with the greatest vote gets elected as president, then the next one with the most votes gets elected as vice president. The one thing I want to bring your attention to is that once you elect a president, that person can no longer be considered to be vice president. So what I'm going to do is I'm actually going to create this tree diagram. It's going to be a little different from what we've been doing, but just stay with me, okay? So president. So first, we got to elect a president. Well, who can you choose to be president? Well, you have all of these people, Wen, Josh, Tamara, Miguel, and Khalil. What I'm going to do is I'm going to abbreviate. So you can either have Wen as president, you can have Josh as president, Tamara, Miguel, or Khalil. Okay? They all can be president. So then once you get elected president, then you have to choose a vice president. Okay? So if one gets elected president, she can no longer be vice president, but Joshua can, Tamara can, Miguel can, and Khalil. So that means that we can have Wen as president and Joshua as vice president. Wen as president and Tamara, and so on and so forth. Well, we can do the same thing for the vice president if we have president for Joshua being the president. Well, this time Wen can be a vice president, Tamara, Miguel, and Khalil. Okay? And I hope you're starting to recognize the pattern. So if Tamara, this is going to look a little ugly. So we can have Wen, Josh, Miguel, and Khalil. Okay? If Miguel is Tamara or Khalil. Sorry, I'm starting to write a little small, running out of space. And lastly, if Khalil is president, then you can have Wen as vice president, Joshua as vice president, Tamara as vice president, or Miguel as vice president. Okay? So that could be a good representation, a good tree diagram for this specific situation. Okay? So take a minute, make sure that you are copying this down. Pause the video as needed. I might be moving a little fast, so if you need the substitute to pause the video, go ahead and let her know, please. Okay. All right, number 2. What does each level represent on your diagram? Well, each level represents either president, and that will be this level right here, or vice president, and that will be this level right here. Cool? It says, does the order matter? Does the order matter? Well, let's think about it. The order in which we start or which we elect president versus vice president, it kind of does. Yes, it does. Because if you remember from the problem, the highest number of votes is president. So first you have to elect your president. Then next highest is vice president. Okay, so kind of the order for this problem does matter. Okay, because again, before you can elect your vice president, you have to know who your president is, and that's all in the problem. Okay. All right, so let's continue. Question number 3. It says, write the sample space as an organized list. Well, the sample space is referring to, if you remember the definition of a sample space, is what are all the outcomes. So if we go back to our tree, you remember that if you can take this last column and count, well, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. There's 20 possible outcomes, and you have to list them all. So I'm going to put them as a list. Now, I'm going to just, because to make this easier, I'm going to answer question 3 right here. So you can be on the next page. I'm going to answer here. Here's the sample space, okay? Okay, so the sample space is a list. It's going to be, the sample space is, and I'm just going to put a list here. You can have when with Josh, when with Tamara, when with Miguel, or when with Khalil. Okay? Or you can have, Joshua with when, Joshua with Tamara, Joshua with Miguel, or Joshua with Khalil. Cool? Or you can have Tamara with when, Tamara with Joshua, Tamara with Miguel, Tamara with Khalil. Cool? Or, I'm going to come down here, you can have Miguel with when, Miguel with Joshua, Miguel with Tamara, and Miguel with Khalil. Or you can have Khalil with when, Khalil with Joshua, Khalil with Tamara, or Khalil with Miguel. Okay? And that takes care of your sample space. So you have 1, 2, 3, 4, and then you have 1, 2, 3, 4, 5. So 5 times 4, there's 20 possible outcomes. Cool? Alright, so that takes care of number 3, so let's kind of move on. So it says, you're going to take a look at your samples. How many of the outcomes result in when being president? Okay, so I'm going to go back to the tree. So how many of the outcomes represent when being president? Well, I hope you realize that these are the 20 outcomes. And out of the 20 outcomes, if I look at my sample space, the first letter represents the president. So which ones have G first? So none of those except for this one. So 1, 2, 3, 4. So 4 outcomes. 4 outcomes represent her being president. But he doesn't want to just know what president. So this is for president. He wants to know for vice president. So for vice president, that will be the second letter. So we're looking for when. So obviously none of those. But, oh, there's 1, 2, 3, there's 4. So there's 4 outcomes for vice president. So the question is how many for either one of those. So it doesn't matter if she's president or vice president. There's a total of 8 outcomes. Outcomes. And that would be your answer. Cool? Alright. Part B says, how many outcomes result in Tamara not being president? So not being president, if I go back to the tree, well, here's where Tamara is president, and it takes care of this 4 right here. So remember how it was 20? I can just kind of think about it backwards. So 20 minus 4 is going to be 16. So there's 16 outcomes where Tamara is not president of the student council. Cool? Alright. Part C. How many outcomes result in Joshua or Khalil being president? And this is important. And Tamara or Wen as vice president. So this is very specific. Well, let's talk about it. Joshua can be president, and Tamara could be his vice president. Correct? Or Joshua could be president, and Wen can be his vice president. I'm sorry. So that takes care of Josh being president. Then you can have Khalil with Tamara, or Khalil with Wen. So that's 1, 2, 3, 4 outcomes. Okay? Alright. Question number 5 is actually a very interesting concept, and I want to make sure we all understand this. The sample space includes both JM and MJ as outcomes. Will this be the same or different? Well, I hope you realize that the order of the letters matter. Remember how we said it on question 2. Because J is first, here that represents that here this is the president and that's the vice president. As far as MJ goes, this is president and this is vice president. So are they the same thing? No, they're not. One of them represents in one of them Joshua being president versus the other one him being vice president. Cool? Alright, moving on. Number 6. Can you rearrange the tree diagram to produce a different number of total possible outcomes for an election? Explain why or why not. Can you rearrange the diagram to produce? Here's the thing. We can rearrange the tree diagram, but will it produce a different number of possible outcomes? If you recall from last class, rearranging tree diagrams does not change the number of outcomes. All it does is just change the order of the different types of outcomes. Cool? Alright, which takes us to question number 7. Consider your sample spaces from problem 1 and problem 2. Well, problem 1, okay, problem 1 was about the whole pizza place with Mario. Okay? So does choosing a topping for a pizza at Mario's Pizza affect any other choice you have? So here's what that means. I'm going to flip back to that problem, which was this problem right here, which is the Mario's Pizza. My question is, does choosing a topping, which was pepperoni or mushroom, affect whether you choose to be thick or thin, or whether you choose to be square or large pizza, or small? And the answer to that would be no. If I choose pepperoni or mushroom, that doesn't determine whether I can pick thick or thin. And that also doesn't determine whether I can have a square or round pizza, which again does not determine whether I can have a large or a small pizza. So let's go back to the question. So does it affect any of the other choices? No, it does not. It's not. Does choosing a size affect any other choices? No, it does not. Why? Well, if you recall from last class, I kind of introduced you to the whole concept of independent versus dependent. And when you selecting something doesn't affect the next choice, that is known as an independent. So no, it does not, because each selection is independent from the previous, So in other words, if I choose for my pizza to be large, that doesn't determine whether it's round or thick. And that doesn't determine whether I take pepperoni or mushroom, etc. Okay? Alright, so let's look at part B. Does selecting a student council president affect the choices of the past president? Definitely. Yes, it does. Once you are elected president, you can't be vice president. Okay? In other words, each choice, is dependent dependent on the previous. So once you elect a president, that person cannot be vice president. So therefore, it affects your next choice. Okay. I hope that kind of clarifies that concept of dependent versus independent. Okay. All right. So that takes care of problem number 2, which was electing a president and a vice president. Again, just a friendly reminder, pause as you need, and just please speak for yourself. Okay? Alright. Problem number 3. Okay? It says that you have the Friday lunch menus available for Franklin Middle School. Here's your entrees, here's your side dishes, and here's your desserts. Okay? Each student chooses one entree, one side dish, and one dessert to make their lunch. Okay? How many lunches are possible with fish sandwich as an entree? Okay, so how many lunches are possible with fish sandwich and entree? Use a diagram to help you determine. Okay, since I'm only using fish sandwich as an entree, that's what I'm going to start my tree diagram as. So fish sandwich. Pick a side dish, because one entree, one side dish. So one of them can be mac and cheese. So I'm going to go up here, mac and cheese. The other one can be French fries. French fries. The other one can be string beans. String beans. And lastly, you can pick carrots. Okay? So you can have fish with mac and cheese, fish with French fries, fish with beans, or fish with carrots. Okay? But you also have to pick a dessert. So once you pick your side dish, you can either choose for dessert to have cottage cheese and fruit. Anyway, so cottage cheese. You can have fruit gelatin, so fruit gelatin. You can have rice pudding. You can have strawberries, or you can have a granola bar. So you have all those. Well, wouldn't that be the same for the rest of them? So you can have cottage cheese, fruit gelatin, rice pudding, strawberries, granola bar. Same thing, cottage cheese, fruit gelatin, rice pudding, strawberries, granola bar. And one more time. So then, there's my tree. So does this answer the question? Well, how many lunches are there possible? Well, remember, count the last column. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. Well, if there's 5 for each, so 5 times 4, so there's 20 possible lunches with fish sandwich as an entree. Cool? Okay. Now I want to bring your attention to what this young girl is saying here. It says, this tree diagram shows the meal outcomes that have a fish sandwich, but the tree diagram that shows all of the meal outcomes will be a lot bigger. I hope you understand that. This is just with fish. Imagine recreating the same thing, but with grilled cheese, hamburger, hot dog, chicken nuggets, and pizza. That means that you would take this and you would have 2, 3, 4, 5 more trees that look like this and have them all connected to create a huge giant tree. Okay? Thankfully, they didn't ask you to do that. So let's see what our next question has. Okay? Alright, so we have Maurice made the tree diagram that shows the following. So how is this one different from mine, probably? Okay? So what's the difference that you notice between your tree and mine? Well, first of all, I started with fish and so did Maurice. I also did the side dishes. But I also did this and here's this. So here's what he did different. Okay? So instead of listing out each dessert, he wrote 5 desserts because there's 5 desserts for each one. That's all he did different from mine. Why do you think he did this? Honestly, to save time. Okay, to save time and because he's noticing a pattern, like it's always gonna be this. What I don't remember what that was. These are the desserts, but it repeats. There's a pattern there. Okay, do you notice a pattern? Oh, I just talked about that. So in your own words, let's just repeat over and over, which with each side dish. Okay, all right. Which takes us to question D. The fish sandwich has 4 possible side dishes and 5 possible desserts. Do you think this pattern will be the same for a grilled cheese sandwich? Well, let's think about it. If I was doing the same thing for a grilled cheese sandwich, wouldn't I still have the same 4 side dishes and wouldn't I still have the same thing? So the only thing that would change that instead of starting here with fish, it would say grilled cheese sandwich. So would it be the same pattern? Yes, it will. How many outcomes will there be with a cheese sandwich? Well, wouldn't it be the same as with the fish? So 20 outcomes. Okay. How many lunches are possible for the Friday menu? Okay, so let's talk about it. So let's go back to the Friday menu. So the Friday menu offers all these entrees. Well, if the fish sandwich has 20 possible dishes that you can have, and we did it here on number 1, the grilled cheese is also going to have 20. So wouldn't it be the same tree, just replacing this word with the entree? So wouldn't it be 20, 20, 20, 20, 20, 20? So 1, 2, 3, 4, 5, 6. 6 times 20 is 120, or 20 plus 20 plus 20 plus 20 plus 20 plus 20. There is 120 possible lunches on Friday. Okay? Alright. I hope you're finding that this whole concept of building a tree and using the tree to answer questions can be relatively simple as long as you have an organized and neatly drawn tree for you. Okay? Alright. Let's flip the page and let's talk about Paula. Because Paula did something different than what I did to determine how many total meals that were offered on Friday, which we came up with 120. So here's what she did. First, she said, I pretended that there were just 2 choices for the entree, 2 side dish, and 2 desserts. So if there's only 2 choices, then she just selected, she just say that you have fish and grilled cheese, and that you only have macaroni and cheese and French fries, and then you only have those 2 desserts. So if you create that, then you realize that with just 2 entrees, 2 side dishes, and 2 desserts, there's 1, 2, 3, 4, 5, 6, 7, 8 total amount of it. So check out what she did mathematically. She said, well, I have 2 entrees, I have 2 side dishes, and I have 2 desserts. Well, 2 times 2 is 4, times 2 is 8. Wasn't that the number of total outcomes that we had here? Interesting. So then she was like, okay, let me see if this continues to work. Now let's pretend that instead of having all those entrees, I have 3 entrees, 2 side dishes, and 2 desserts. So then she pretended that she only had fish, grilled cheese, and hamburger, and did the same thing. So let's count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 possibles. Okay? So let's see if this whole concept that she used works again. So she had 3 entrees, 2 side dishes, and 2 desserts. 3 times 2, 6 times 2, 12. I think we're onto something. I think we actually found out a way that we can save a lot of time for this types of problems. Are you ready? So for that problem, if I was trying to figure out how many total possible lunches are there on this Friday, well, on the original problem we had 6 choices for entrees, 4 for side dishes, and 5 for desserts. 6 times 4 is 24. 24 times 5 is 120. And as you previously saw, that is when we constructed the tree and we did all that long process, we also got 120. So I hope you can see that this is definitely going to help us out and save us a lot of time if we can just multiply the number of choices for each category. Okay? Alright, very good. So here's what I'm going to do. We're going to go ahead and the frozen yogurt problem we're going to go ahead and skip. So I can go over that in another time. So here's what I need you to do. you're going to go to problem, page number, 1166. Okay? Alright, so let's go ahead and get started. 1166, it says, to determine the total numbers of possible lunches in problem 3, Paula used a mathematical principle. So that's the problem we're talking about, and that's called the counting principle. Okay, so let's go ahead and highlight that. The principle is used to determine the number of outcomes in a sample space. Okay? The counting principle states that if an action A occurs in m ways, and for each of these m ways an action B occurs in n ways, then the actions A and B can occur in m times n ways. Alright, that's super confusing. All that is saying for you guys is that to take the number of selections that you have on the first one and multiply by the number of selections that you have on the second one, and that's going to give you total number of outcomes, or your sample space. Let's kind of try it, okay, because I don't really like how they explain this. So I'm going to show you one problem. So here you go. Devin has an all-day pass for Scream Amusement Park. His favorite rides are the Bungee Buggy, the Head Rush roller coaster, the Beep Beep go-karts, and the Tsunami Slide water roller coaster. He never rides any other rides, and he can ride each of his favorite rides as many times as he wants. Alright. Describe the type of event for selecting the ride. Does this situation involve independent events from... Okay, let's not worry about disjoint sets, or let's just worry about independent events. Let me pause for a second. I think we're going to have to go back and talk about disjoint sets. Okay? I apologize. I think I am going to have to talk about that. Alright, I need you to go back. Okay? So we're going to flip back a couple pages. I'm sorry. I apologize, guys. Go to page 1161. I'm sorry. Okay? 1161. Okay? Alright, on page 1161, there's a couple definitions that you're going to have to highlight and keep in mind while we answer those problems. So we'll go back to that problem in just a second. First of all, let's look at the definitions that you're going to need. Okay? It says a set is a collection of items. If X is a member of a set, then X is an element of the set. Two or more sets are disjoint sets if they do not have any common elements. Two or more sets are intersecting sets if they do have common elements. Consider the following examples of disjoint sets and intersecting sets. No, we're not going to do that in this class. Again, I apologize. Okay, I think this gets too confusing for what I need you to know. So let's go back to our problem, but we're going to change the wording a little bit. Okay, I apologize. Sorry. Let's go back to this problem, but we're going to cross out some words. Okay. First of all, let's go back to the question. This person was trying to. He's got an all-day pass. There's all the rides he wants to ride, and he can ride them as many times as he wants. Okay. So it says, are they going to be independent events? I don't care about whether they're disjoint or if they're from the same set. Okay? Well, let's talk about it. First of all, are they independent? Does selecting one determine what selecting the next one would be? No. If I select to write the Head Rush first, that doesn't mean I have to write this one next or this one next. I could write that one and then write it again, and then go to the Tsunami Slide, and then go back to the Head Rush. Okay? So these are independent events. Now here's the thing. Is repetition aligned? Well, I hope you see that it is. Repetition is allowed. And you can use your own words to explain, but I think I can understand if you just write down independent and repetition allowed. Okay? It says, use a counting principle to determine the number of possible ride orders for Devin's next two rides. Explain your reasoning. Okay, so next two rides. So let's talk about it. So for the very first ride, so right here, this is the first ride. How many possible choices does he have? Well, he can choose to either ride the bungee, the Head Rush, the Beep Beep, or the Tsunami. That's 1, 2, 3, 4. So he has 4 choices. Cool? And then it says, what about, it says for the next 2 rights. So that's the first right. So the second right, we said that they're independent, so it doesn't matter. And repetition is allowed. So for the second right, he can write the exact same rights. So he still has the same possibilities. So if you recall, again, the counting principle says that if you have both of them, then all you have to do is take the number of possibilities for one event and multiply by the number of possibilities for the other one. So in this case, you're going to do 4 times 4, so that is 16. So that's 16 possible ride orders. Okay? He says, how about for the next 5 rides? Well, again, since each event is independent and repetition is allowed, wouldn't it be for the first one is 4, for the second one is 4, for the third one is 4, for the fourth one is 4, for the fifth one is 4, right? So 5. 1, 2, 3, 4, 5. So you can use your calculator here. And some of you guys are going to realize that you can either do 4 times 4 times 4 times 4 times 4, and that gets you 1,024 possible rides. And I think some of you guys will recognize that this is the same thing as saying 4 to the 5th power, and you can try it on your calculator. If you do 4 to the 5th power, you get the exact same number. Cool? Either way, I would accept it. Okay? So here's what you're going to do for the rest of class. You're going to answer the questions, the remaining questions. So you're going to answer question number 2, question number 3, question number 4, 5, 6, and 7, using the whole concept of the counting principle. If there's anything arising about disjoint sets or joint sets, just disregard. You're going to work on that, use the counting principle. You can use tree diagrams if you like, but honestly, using the counting principle can save you a lot of time. When you are done with this, I'm going to need you to rip it out of your book, staple it, and turn it in for me, okay? And when you are done with this, so you're stopping, like I said, at problem number 7, which is page 1168, then you are going to grab this worksheet and you are going to work on this. If you finish it, turn it in. Whatever you don't finish will be for homework. Okay? Alright, I appreciate your understanding, and I will see you guys on Wednesday. Okay?